Welcome students to this screencast regarding square roots and cube roots. Let's go ahead and get started. To begin with, we need to understand some of the symbols that we'll be using. And first let's talk about a little bit of terminology. I think utilizing the last screencast, we'd understand that if we wanted to square a number, say for instance 2, and raise it to the second power, well, 2 squared really means 2 times 2, which equals 4. So here written in the exponent form, here 2 squared written in the standard form. Well, it turns out that when we square something, there's actually an inverse operation. So the inverse operation of squaring is the square root. And remember, inverse operation is something like multiplication and division. Those operations undo each other. They're the inverse operations of one another. Another inverse pair would be like addition and subtraction. And we would write the square root using something called the radical symbol. So that's the radical. And any number placed under the radical is called the radicand. So for instance, say I want to take the square root of 4. 4 is called the radicand. So radicand. Well, if we know 2 squared equals 4, then we know the square root of 4 is equal to 2. Those operations undo each other. Why? We'll take a look here. Square root of 2 squared, it's as if these two operations cancel each other out. Get rid of those two, and what are you left with? Well, you're left with 2. So being that the square root is the inverse operation of squaring, we know the square root of 4 in this case is equal to 2. Now sometimes you may have to use your knowledge of squares to come up with the square root of a number. Say for instance, I want to know what the square root of 169 is. Some of you may or may not be able to do that really quickly off the top of your head, but hopefully you think in your mind, especially if I told you 169 is a perfect square, you would think, well, 10 times 10, that's 100. And that's close to 169, so let's keep going with my perfect squares. And hopefully if your perfect squares are sharp, you know that 11 times 11 is 121, which means we're getting a little bit closer. You know that 12 times 12 is 144. And you're that much closer, so let's try 13 times 13. Well, 13 times 13, hopefully if you're sharp on the perfect squares, that's 169. So we're looking for what number multiplied by itself would give us 169, and we found it. 13 times 13 is equal to 169. So the square root of 169 is 13. And why is that? Well, because 13 times 13 is equal to 169, or better written, 13 squared is equal to 169. So that's a quick introduction to square roots. Now what about cube roots or cubic roots? Well, and we write that as CUB, cube roots, or cubic roots. Well, one thing I didn't mention earlier is another part of the radical. So if you remember, we have the radical sign, then we have the radicand, whatever number is underneath here. So let's say, for instance, 64. Well, when we do square roots, we understand this number here to be a 2. And we actually don't even write it. So for instance, square root of 64, well, what number multiplied by itself is 64? Well, that's 8. This number 2 is called the index. Okay? And that's square roots. Well, what if I want to deal with cube roots? Well, let's go back, insert our symbols again. The only thing that changes is the index. Notice cube, that should elicit in your mind 3. Notice a cube is a three-dimensional object. So instead of an index of 2 when we dealt with square roots, We have an index of 3. So what multiplied by itself 3 times would give us 64? Well, you may not be quite as sharp on your cube roots, but we know that 1 cubed is 1. We know 2 cubed, well, that's 2 times 2 times 2. Well, that equals 8. 3 cubed, well, that's 3 times 3 times 3, which is 27. So we're getting closer. Let's try 4 cubed. Well, 4 cubed is 4 times 4 times 4. Hopefully you notice 4 times 4 is one of your perfect squares. That's 16. Well, when you multiply 16 times 4, you get 64. So what's the cubed root of 64? Well, what multiplied by itself 3 times is 64? 4. That's how we do a cubed root. That's going to be it for this screencast. In the next screencast, I'll show you how to estimate square roots and cube roots.